Are we okay
Morning.
today? Morning.
Okay, miss.
Mm. Okay, did you read your notes? It's today lecture is going to be a very long one. So like usual, on how we did the last week, yeah, we will divide that into half. Because if you see, we have how many slides? We have about 50 plus 60. Yeah. So it's a very long slide. So what we do is we are going to do half if we can, and then the one which is left behind, we will continue during our practical for about like 20 minutes or so. Yeah. So if you can see, if you look at your notes for today, chapter 4, array implementations of collection ADTs. So what do you think? Basically, this one is trying to get you recall back on what we have learned in the previous chapter about ADTs, right? So did you read your notes?
Oh, haven't yet.
No?
Oh no.
No? What do you think of the notes? I mean, what do you think of the topic? Any problem with trying to read it? Let's see myself. Okay. So anyway, if you look at it, right, I think it is a bit heavy if you did not know what is the function. But since you guys have already done that programming, so you guys should know what exactly is this. Yes. So I feel you could also contribute your experience in this when we go further in the chapter. Yeah. So okay. Uh, let's start and with this one. I need to something wrong with my machine just now. They were so heavily loaded. I was trying to do something, then it hanged, and I get to reboot and reboot. Sorry about that. Delete. Okay. Wait. Just do some chapter 4. So as usual, this is my version. Yeah, I try my best to actually add a bit of notes for you to recall back. Okay, so I hope that this elaboration can bring back your recollection of the array implementation, which I suppose you already understood it because you did it in your um, what do you call that? Your practical, yeah, an
Yeah.
assignment, right? Should be easy to understand. So with this as well, I need you probably share some of your experiences using it. Okay, so we go through this together. Okay, so this is the topic, chapter 4. So, yeah, screen. Okay, so first thing before we start, you need to know what are your learning outcomes. This is what you are going to learn at the end of this chapter. You should be able to implement a DT list, stack, and queue using arrays. But I believe this is you already done that, so you know that already. You have experience doing it. So, but I'm not sure whether you know the terms and what it does. Of course, you know what it does, but I don't know whether you can actually describe the terms exactly, right? So maybe this one we can share with you later on. So anyway, discuss the strength and weaknesses of using arrays to implement the ADTs. Okay, and then what are the strengths? What are the weaknesses using arrays to implement the ADTs? Analyze the efficiency of the array implementations of the ADTs, abstract data types. So there are several abstract data types that you know, right? You have list, stack, queues, arrays. So those are what we're going to analyze in this chapter. Now, recall, you want to create an ADT in your assignment. Basically, we're supposed to create an ADT of your own. Okay, it's a bit challenging because you're not supposed to follow any sorts of example source code which was given during the class or any time uh, yeah in the class which was given to you. So this one is basically the steps which you are following. Step one, write the ADT specs. Okay. Step two, implement the ADTs. Step three, use the ADTs in a client program or application. So what is happening at step one? So you basically trying to identify what kind of abstract data types that you want to include into your program. So based on our practical, we have several ADTs that we have used, stacks, and then we have that is during the week, first week or second week or first and second week, yeah, stacks, and then we have list and we have queues. Okay, so I hope you have done that, and then experience how you manipulate arrays, stacks, and all that in your program. So write write an ADT specs which describes characteristics of the data type, because this ADTs is actually you define what is an object, that you define behavior based on the values and also the operation that it can do, right? So you to manipulate your data which you have in your program. Okay, and then it says here it should not include any implementation or usage details, because usually if you want to actually bring up ADTs, you want to only know what it can do, not how it is doing it. Okay, so that is going to be described further in the topic. Number two, implement the ADTs. How do you implement that? First thing is you have to write a Java interface. So in your interface, you include all the operations from the ADT specs, and then you basically declare it in there, and then with your specification of how ADT is supposed to be, instances, exceptions, okay, classes, methods, how you do that implementation of ADTs. We write a Java class. This class implements a Java interface from here, your Java interface, and then it determines how to represent each data which you are going to call in your method, and then implement all the operations from the interface as well. So that is where it compiles and do the execution of whatever is in your interface. Okay, so that is implementation of the ADT step number two. Next one, use the ADT in a client program or application. Okay, so you have created your program, so now you want to use it in your client program to execute, to be able to call upon those methods which you have created and then execute so that it can produce what you wanted for that program. As in now you are trying to create, I think you have an assignment of how you selected catalog system. What is that? Music catalog system? Yes, Noel? What are you selecting for your
Uh,
assignment?
Karaoke.
Mm. And then karaoke. And then what about Kelvin? Kelvin is using is
The
trying,
group buying,
which one? Sorry?
the group, the group buying.
Yeah, okay. That buying, group buying. Yeah, okay. So basically, have you actually created like some of the modules? I mean, not some. You're supposed to create one module, and then you're supposed to have functions for that modules, right? Have you managed to actually create one at least? Yes, guys?
Haven't
Yes.
started yet.
Okay.
Right.
Haven't started. Oh, okay. You should analyze on that one. Yeah. So anyway, so that is where you use the ADT in your client program or application, because that's why when during our practical, we actually did a lot of exercises to get you familiarized with how you're going to execute that in your assignment. Okay, but of course it is a little bit challenging. So this is where we learn on how you execute that by using all these instances in this particular chapter. Okay, let's move on. Okay, an ADT that can store, this is a collection of ADTs. There is a document which was furnished by the course leader. I'm not sure if I have given you, but I shared here. It is a collection of ADTs that can store a collection of objects. So basically, some ADTs are linear collection that stores entries in a linear sequence. So example, you have here list, stacked, and queue. And then of course they differ in restrictions they place on how these entries add data, remove data, or access your data. So for example, here you have stack uses LIFO, as you know, right? Stack last in first out method to access and add data elements. Queue uses LIFO, first in first out. Okay, because like how you queue when you want to buy ticket for your cinema used to be. Okay, a long time ago, people buy tickets, they have to queue. Buying food at the counter, you have to queue. So when you queue, that means the first person who queued would be the first one who gets served. So same concept with queue. Queue here uses first in first out method to access and add data elements. So next one is linked list. List can be used to depict a first in first out as well as last in first out, because linked list has list that of arrays that is interconnected, elements that are interconnected, and you add either from the front or at the back, similar to queue. So it can basically do FIFO or LIFO, like stack and queue. So it's kind of flexible for linked list. All right. Now this is your list. This is just basically how you do your listing. You list down everything what you need. And then a list provides a way to organize your data. Okay. So basically you want to organize data, you use your list. Operation in your list includes add new entry from the end or from anywhere else. Okay, that is adding your entry. You remove an item. You replace an entry, get an entry at a specified position in your list, as well as how you count how many entries that you have in the list. Count is a very important word for ADTs, because it can actually help you to expand your array in your ADTs. For example, if you use it in a list or use it in a array, yeah, list that is. So check if list is empty or full. Okay, so those are operation on your list, because there is a question on count. There is what if the array which you have in your list is full. So full meaning that you have declared, uh, mm, for example, the number of elements that can fit in an array is 10. So therefore, what if when you are trying to add an element in that list, right, in the array which is inside there, how would you be able to add more? What do you think? What would you be able to add more? Okay, so there is a way on how you do that. Basically, use count, right? So when you use this count, it can automatically expand the size of your array to fit a new element. So that is later on. Yeah. Okay. Step one, elaboration. So this one is actually referred to Appendix 4.1. 4.1 list ADT specs. Okay. I think I have this with me, Appendix 4.1. Hang on, did I attach here? Oh yeah, this is the one. So this is your Appendix 4.1. Do you have this? Did I give it to you?
Oh, wait now.
Do you have this? No?
Is it in the lecture slides?
Hmm?
Is it in the lecture slides?
Yes, it is in here, but it is an individual. It is an individual file by itself. So I just add it here so we can share during lecture. But this one is an individual file by itself. But anyway, mm, so it says write the ADT specs. ADT specs basically is listed in the appendix 4.1 for list of ADT specs. So note that in this specs, it says entries in the list have position that begins with 1. So for ADT specs, it is here, it says they position your list automatically begins with 1. Okay, so that it can achieve consistency in your everyday life. So it says you should not think, okay, this is what I mentioned. Yes, when you want to execute you or you want to use an operation in list, you should only think about what the operation can do, um, not how they do them. Okay, so basically these are the functions of the ADT list specs. Okay, a list is a linear collection of entries of a type T, okay, generic T, which allows the duplicate elements. An entry may be added at a specified position or at the end of the list. The list position starts from 1. Okay, so these are the function that you can use, ADT list specs, okay. ADT T new entry. So here you have an element that you declared as T using generic data type. Okay, that is to basically enable you not to use too many declaration, as in when you use primitive data type. So T is used. And then this description, it says that add T new entry. So description is add new entry to the end of the list. Post condition, new entry has been added to the end of the list. And the next one, Boolean add integer new position T and new entry. Okay, description adds new entry at position, a position within the list. Position 1 indicates the first entry in the list. Okay, so all these things are edited list specification, which you can use in your program. Okay, and these are the explanation of what it does. So now the main thing is that you need to know only what the operations are and what they can do, not how they do it, because you don't want to look into the internal part, you want to just look up on the outer part. So this you can use to execute that. Okay, these are the function description, and this is a false condition, and what it returns to you, which is here returns. Okay, all has returns true if new entry was successfully added to the list, false otherwise. Okay, okay, all right, these are the issues to consider for the operations. So you have you can add, can remove, replace, get entry work. Okay, get entry. So all this works okay when valid position is given, right? You can do adding of data, new data. You can remove new data. You can replace. You can get entry for new data to come in. Okay, so these are the words or the uh, what do you call that? The terms that you can use in your program. So these can be executed and valid when a valid position is given. And then remove, replace, and get entry not meaningful on empty list because there is nothing to retrieve, there's nothing to remove, there's nothing to get entry. So you have to have a list declared, as in how many, for example, what is the number of entry that is allowable for an element to be into the list, going into the list. So here, this is a question here, is always happen in any of the linear ADTs. One question is that it says a list could become full. What happens to add? You get what it means? if a list is full, you declare that particular array in your list of 10 elements to be allowable to enter. So what if 10 capacity is already um, finished? You already completed all. You mean you already have all fulfilled, all 10 filled up. So what happened? So this is where you go towards handling it by using an operation called count. Okay, so notice if sometimes there's a program that you do counter count. Count is the number of elements that are actually in the array list. Okay, so capacity is always greater or equal to count. So in here it says that if you put this counter count, it is whenever you want to add another one, it will automatically add or it will automatically expand your capacity of the um, internal array and allowing that new element to be entered in the list. Okay, so there is also another way of how you're doing it. You basically create another set of array, means you transfer the old elements into the new array, which is a bigger one. So that is a way on how you solve this problem. Okay, so this one is says automatically increase by relocating the internal array before copying the old elements and adding the new elements. Okay, so that is one solution I put here. Design issues. Uh, when you specify an ADT, you need to decide how to handle special or unusual conditions. And the ADT specs should include details on how the special condition would be handled by various operations. What does that mean? Sometimes when you execute or you want to write a program, and then there is a problem along the way when you're trying to compile, especially when you want to embed that into your module in your program. So then something wrong with the code, for example, because you did not declare something. Here is the example of your unusual condition. Okay, first is a user enter an input value of the wrong type, for example, meaning if you want to enter your um, password, allowable value would be that you need to enter only alphabets or password. Yeah, alphabets, integer, um, values only. And you do not allow some other like special characters, for instance. So some you want to create that and you accidentally entered the invalid data type. So therefore, it should gives you some sort of uh, you call that the error messages coming in. Okay, so next one is while handling if reading information from a file, the end of the file is reached. Okay, there is then you will get an error message or problem, unusual conditions. Okay, so how are you going to actually handle this? So here is a solution handling unusual condition using Java exception mechanism. Okay, so you have to add an exception, Java exception mechanism. See, so this is the one. You want to throw an exception. For example, here you want to write a date constructor to check for legal month and years. Okay, so you declare public date and all those details in your program. And then after that, you want to throw date out of bound exception to basically check. Okay, to basically check whether the user entered the right month, the right day. Yeah. So therefore, if it is incorrect, then you throw an exception, date out of bound exception for this to put either out of range for new month or the year is too early. Okay. So this is basically a way on how you handle unusual conditions in your ADTs. You have to add all these an exception handling your unusual conditions. Get what I mean? So this one sometimes I'm not sure if you realize you actually already done this. You put this kind of handling exception in your codings. And do you realize?
Oh yeah.
Yeah, you actually did this already, right? How you handle this one, unusual conditions. A user enters an input value of the wrong type or reading information from file, the end of file is reached, and then what happened? So how you handle that, you have this way of handling it. You put this kind of handling exception. Okay, so these are what it is by handling throwing an exception. Okay, right, next one is these are your solution. Assume the invalid situation will not occur. Ignore the invalid situation. Make reasonable assumption, act in predictable way, return Boolean values indicating success or failure of the operation. Try an exception. This one is already mentioned, yeah. This one. Yeah. So what about this one? Boolean, you have already done this as well, Boolean value, right?
Oh
Yeah,
yeah.
this is this one is a return Boolean value indicating success or failure of the operation. So here, this is an example of how you use Boolean to get the user and to check whether the data which was entered is valid or invalid. So you use this kind of Boolean values indicator to indicate success or failure of the operation. So over here is Java program illustrating parse Boolean and value of method. Okay, so as you can see, declaration of the Boolean B1 equals to false, B2 equals to true. So all this use of value method is stated here. Uh, Boolean validation value number one equals to Boolean dot value of B1. Okay, so Boolean value 2, Boolean value of 2. And then this is what you execute. All right, and then you do this validation check. Yeah, and then after that you execute the output, which is value of B1 false, value B2 true. Okay, this is basically trying to give you a clear indicator of how you use or execute a boolean yes, true or false in your program. Yeah, so you already done this. I think I've seen it in your code. Yeah. Mm. Now, step two, implement the list ADT. Step 2a, write the Java interface contains the method declaration of all operations listed in the list ADT specs. Okay, so all the methods are abstract methods. Okay, basically, your methods are concealed, your methods are hidden. Uh, it is inside your declaration, only you know about that, and the system knows about that. And therefore, you put it into your Java interface. So here, example of abstract method which was given to show how it was implemented is actually shown in this sample list interface.java. Okay, so I cannot provide it here because it is a bit too long for this space to show. But I gave you a different sample of program for you to see the illustration of how abstract methods is basically executed in the program. So here it says abstract method is a method that has just the method definition but does not contain the implementation. Main purpose is because you want to be able to reuse. Okay, you want to be able to call method whenever you go to a different function, and you don't want to repeat the same thing. So a method without a body is known as an abstract method. It must be declared in abstract classes. So when you this is basically calling of method, right? So when you call the method, it will execute uh, action that will be executed in that particular class itself, which is, if you can see here, yeah, the abstract method will never be final because abstract class must implement all the abstract methods. Okay, so if you see this illustration, not illustration, this description of this particular abstract uh, class, yeah. So you have class demo implements multiply. Okay, first thing is the interface. Interface multiply. This is your abstract method. Public abstract int multiply to your declaration of integer number one, number two. Okay, so this is whenever you write abstract methods, you have this declaration. Okay, public abstract integer multiply. This word, yeah, abstract has to be in there. So it can be accessed publicly wherever it is in your program, provided that you include that in your classes. So it says here we need not to mention public and abstract in interface as all the methods interface are public and abstract by default. So compiler will treat this as public abstract multiply. Okay, so that is what I mentioned. Yes. Okay, and then after that you add this declaration of your interface into your class abstract class. Yeah. So then it will execute. You call the method, it will run into your class. So class abstract method runs together with your abstract class. And then this basically gives you an output of what you need to, okay, which is plus the addition of number. And then, yeah, values which you need to be output from this particular program. Okay, so this is just an example of how you illustrate abstract method in your abstract class. Okay, right. So this one is a video on how you, yeah, you actually uh, get your abstract method to be added. Just
Exploring abstract method. Currently we are in section 18 and we are about to check out the second video of this section. So in this video we will check out the abstract method. So within our application, let us go ahead and define our abstract method. So how to define an abstract method? Of course, you have to use again the abstract keyword. So down below here within the abstract class, we can use the abstract keyword followed by the public modifier, and then let us define our eat method. And within this, let us define our body. Now here we have some error. The abstract methods cannot have any body. So let us check out our rule number 1. So whenever you define the abstract methods, the abstract method contains no method body. That is, you cannot write any code within the abstract method. So here, as per the rule, we cannot define this statement here. Let us remove it, and also the method body, let us remove it. And end the statement with the help of a semicolon. So this is the perfect definition of defining the abstract method in case of Java. Fine. Now you must be thinking, since the method is blank, so what is the advantage of creating the abstract method? So for that, let us look at our rule number 2, that it is mandatory to override the abstract methods in the child class. Now remember, the animal can have the child class of dog, cat, lion, and tiger, and so on, right? So here, let us define our class of dog, which extends from the animal. So the animal is now our parent class. And within this, as per the rule number 2, it is mandatory to override the abstract methods of the superclass in our child class. Fine. So in our parent class, animal, we have one abstract method of eat. And as per the rule, we have to override this method within our child dog class. So here is the error. The dog class must either be declared abstract or implement the abstract method eat in the animal class. So here what we have to do, let us override our eat method by using public void and eat. Now once you do it, you will find the @ override annotation. So whenever you override any method, always remember just use @override annotation so that it will notify the compiler that we are actually overriding a method within our child class. And now within this method, let us define our code. This time dog is eating. Perfect. Now how to call this method of eat? So for that within our main method, here you can go like this. We can define animal space animal. Now, as per the rule, you cannot create any object of the animal class, which is abstract in nature. But you can actually create the reference variable of the abstract class, which is allowed in Java. So here is the comment statement for that. Perfect. Now you must be thinking, since we are allowed to create the reference, so what is the advantage of that? Because you cannot instantiate the animal class. What I'm trying to say is, here you cannot use animal space animal equal to new animal. It is not allowed, right? But as per what we have learned in our previous video, you can actually create the reference variable of the parent class, and on the right, you can actually instantiate the object of the child class. That is, here, if you use dog object, then it is actually allowed. So basically, on the left, we have the parent class reference variable of animal, which is pointing to the child class object. And such concept we have already covered in our previous videos, so please make sure you check out my previous video as well. And now, using this object of animal1, you can actually call eat, and also you can call animal1 dot run. Perfect. So this eat method is simply going to trigger this method here within the dog class. And this run method, it is simply going to look for the run method within the dog class. Since it is not present, so it is simply going to call the run method within our animal class itself. If you run the code right now, then you will get the desired output. Now let us take a step ahead and further discuss more concepts. Since within the class of animal, which is abstract in nature, we have the public void run method, which is actually the normal method. So within the class of dog, which is the child class, you may or may not override this method. That is, if you override this method here, public void run method, then it is actually optional to override the normal method within the child class. You can actually remove it as well. It is totally up to your wish. But in case if we have the abstract method, then it is mandatory to override it within our child class. Always remember the rules that I have mentioned here. Perfect. So that's all for this video. So in this video, we basically checked out the abstract methods and also how to create the object and call the functions that belongs to the abstract class and methods. Well, to summarize what is the abstract method, you can say the method which is declared abstract is actually known as the abstract method. And the abstract methods contains no method body. That is, you cannot write any code within such method. And now it is mandatory to override the abstract method in the child class, which we saw just now. So that's all for this section. So coming up next in the next section, we will check out what are interface in Java. Exploring abstract method.
Okay, are we clear about the abstract method with the video example?
Yeah.
Yeah,
Yeah.
good, right? So this one is the key feature of abstract method. Okay, abstract methods don't have an implementation body; they just have method signature, as shown in example here, like that. And also in the video, it shows also how you should represent your abstract method. So if a class, again, this is reiteration of the video, yeah. If a class has an abstract method, it should be declared abstract. The vice versa is not true. That means you need to declare, uh, yeah, you need to declare it in your main body. I mean the main heading, and then after that you have to override that in your class, the child class. Okay, next one, instead of curly braces, if you notice, an abstract method will have a semicolon. Okay, it doesn't have curly bracket at the end. So if a regular class extend an abstract class, then the class must have to must be implemented in all the abstract methods of the class, or it has to be declared abstract as well. So basically the word abstract is important to be declared in all the classes which you have underneath the abstract method. Okay. Next one. Write the Java interface. So this one you have done as well. Data field in Java class. You put that declaration of a generic data T, arrays of list entries, integer number of entries, current number of entries in the list. So note that T represents the data type of the entries in the list. It will be defined as generic type within the class. What is the importance of generic type? I think I put that in the next slide. Yeah. So anyway, data field in the Java class, an array to store the elements of the list. Right? So that data field that you have in your Java class, an array, right? A Java interface, right? You have an array to store the elements of the list, and also you have an integer variable to keep track of the current total number of elements in the list. So these are what you have, data fields in your Java class when you want to write that Java interface. So use in Java interface and classes this generic type T. Which one is that? Let me see. Where's that? Yeah, this one. Okay, why you put it there? Because you do not want to use primitive data types, or you want to allow more data type acceptable in your program. Because sometimes you want to declare, right? You need to declare integer, you need to declare your long, float, double, boolean, all that you need to declare. But if you use T, which is your generic data type, so that basically allows you to get all types of data to be inserted in your program. Okay, next one. Yeah. Yeah. The interface name or class name is followed by an identifier, generic data types, yeah, enclosed in angle brackets. So like such, yeah. Public interface, list interface T. The identifier T, basically this T, not only that you can use T, you can also use any other identifier like some other alphabet, but for generic type, which is usually default use for in your program, they use T. Okay, so identifier usually is in caps, capital letters, and represents the data type within the class definition. So it here used in Java interface and classes which implement collection of ADTs. A while ago, I showed you the collection of ADTs, and then which you can actually use in your program. Okay, those are the objects that are being stored in the collections for you to use. Okay, so when you use the class, you supply an actual type argument to replace T. For example, list interface string task list. Okay, so here now whenever T appears as data type in the definition of list interface, string will be used. You can actually use other type of your data types, which you usually have to declare in all the other places of your class. Okay, so note generic type must be a reference type, not a primitive type. Okay, it has to be reference, not the one that you use usually for your primitive data type as a declaration. It is a reference. Reference means you can actually use some other data type, which is referring to your primitive data type in your program. But as a reference, it allows it to be declared or inserted in here, list interface. So that means you can use that. Okay. All right, so here is a video on your generic types. I hope this one is okay to get you understand.
Welcome. Today I'm going to show you what generics are in Java, how they make your life easier, and how to implement your own classes and methods that use generics. Generics as we know them today were first available in Generic Java, a community mod released in 1998 by Gilad Bracker, Martin Odisky, David Stoutsmeyer, and Philip Wadler. Gilad and David worked for JavaSoft, which was the part of Sun responsible for developing Java, although the project was initially independent. In 1999, Gilad proposed that generics were added to Java based on the ideas from Generic Java, and they were eventually officially added to Java in 2004 with the release of Java 5. Generics allow the author of a class or method to introduce type parameters, which are symbols that can be substituted for any concrete type. You've probably seen generics around before. For instance, the list interface has the generic type parameter E, which is the type of elements in the list. When you use the list interface, you normally substitute this for a concrete type, like string or integer. Before generics, there was no way to tell Java that a list only contains strings. You could only create lists that could contain any sort of object. This had a few major downsides. First, it's a hassle to use. Whenever you want to get a string back out of the list, you would need to cast the object to string to be able to work with it. Second, it introduces bugs. The compiler doesn't know that I'm not supposed to be putting integers into this list, so it's not going to stop me. But if I try to run the program, then a class cast exception happens at runtime when I try to cast the integer to string. Nowadays, your IDE will complain at you if you're not parameterizing your lists. Now I've parameterized this list with string, I'm being told that I can't put an integer into the list. I'm also being told that these casts are unnecessary. The other thing that's unnecessary is the second string on the right-hand side of the equals sign here. Since Java 7, Java's smart enough to figure out what the type parameters should be in some instances, using a process called type inference. So I can just use an empty diamond here. In fact, type inference is getting better all of the time, and more recent versions of Java are able to infer generic type parameters in more and more situations. The last major benefit of generics is that they allow you to write generic classes and algorithms. We could have eliminated casts and provided stronger compile time checks for lists by implementing a special string list object. The trouble is that we would then need to create an integer list and a double list, and in fact a bespoke class for every type of object you'd want to put in a list. With generics, the author of the list can just use the symbol E everywhere, and that will be swapped out for the particular type that the user needs, even types that didn't exist when the list was first implemented. Now we know what generics are and how to use them, but how do we implement a class that uses generics? Look at this one, pair. It takes two strings in its constructor and has getters for them. It's just a simple way to carry around exactly two strings. One day, we realized that we need to have pairs of integers too. We can employ generics to reuse this code. What we want to do is introduce a type parameter, which we do right here. We can do the same thing with interfaces as well. By convention, we normally use the letter T as our type parameter, but actually, it can be anything. Now we replace all of the occurrences of string, except for the one in toString, to T. The compiler will understand that any time T appears in our pair, it refers to the type that the user provides when they construct an instance of pair. Now we can create a pair of integers. In fact, we can create pairs of anything. Here's a new class, person. We can create a pair of people. You can have multiple type parameters in the same class. You've probably seen or used the map interface, which has two type parameters, one for the keys and one for the values. Maybe we decide that we want to create pairs with two different types. We can add another type parameter right here just after the first one. Again, by convention, we normally use s as the second type parameter, but we don't have to. This time, we want the second element in the pair to be of type s. So we need to change the type that second is stored as, the type that is set as in the constructor, and the type that is returned in the getter. Now our previous pairs need to define both type parameters. But we can create pairs of strings and integers like this. Real quick, if you're enjoying the video, please give it a like and subscribe to this channel for more videos about.
Okay, that is about generics types. Yeah. So I hope it is clear based on these videos. So there is a benefit of using these generic types. Yeah. So you don't have to actually declare your integer, declare your string, characters, and all that. So you can accept everything by just adding T, which represents the generic data type acceptance of the types in your program. Yeah, you've seen it just now. So this one is for the explanation on that. I share here so you can read as your notes. So here is the generic types. I added here because it's so easier for you to understand, again, based on the video and also in a version where you can read. So why do you need generics in Java? When we write programs, error occurs. Sometimes this is how you explain why is the urgency of generic. Yeah. So when we write programs, sometimes error occur. Some errors occur at runtime, as the video mentioned, and some occur during compile time. So those errors which occur at compile time can be easily detected, okay, and rectified in the program. But sometimes a runtime error occur when an application is running in real time, and these errors cause the program to crash, and it's hard to track them down. Okay, so you use and then also these runtime errors go unnoticed at compile time. So that's why you use generics in Java. Okay, I'm not sure whether you guys have used this, but this is the learning outcome for today. How you could actually see which particular ADTs can be manipulated with certain data type that you can reuse or use in your program. So advantage of generics, as mentioned in the video, is that it provides a type safety, so you can hold a single type of object in generics. Okay, that means single object means not only that you can accept strings, you can also accept some other like integer, okay, and without having to basically declare it in the top interface. Okay, it provides a compile time checker, so it doesn't show an error at runtime. There's no necessity to typecast an object. Typecast meaning that you need to basically put the word string, for example, like you see in the video, in every time you want to call upon that particular object to appear. Okay, so there is no necessity to typecast an object. Disadvantage, we cannot use casts or instances, yes, with parameterized types. So this is the example of your program that is not allowed. Okay, we cannot assert static field. You cannot use public static TOS. Okay, that is your declaration of your parameters. And then you cannot also personalize generic types with primitive types together. Yeah, you have here the value of K key and the V value. So you cannot put this. This is not allowed. Okay, primitive type, which is referring to your all these integers and values of float and all that. Okay, so those are in your primitive types. So here is the summary of your generic types, why you need it in Java, advantages, disadvantages. Step 2, write Java interface. Still under here, you want to implement interface list interface. So operations are implemented as Java methods, as explained before. That happens in your list ADT specs, also interface list interface, which is happening inside your system, your program, and then also some utility operation, which is happening at your external core of the operation to support core operations, okay, which is actually implemented as a private method which protects or execute what your core operations are supposed to be doing. So operations are implemented as Java methods, core operation as appear in the list ADT, specs also interface lists, utility operation to support core operations. They are implemented private methods. Okay, so this is the method. Add new entry. You have this in the list. Adds a new item at the end of the list. You basically assign a new value at n, and then you increment length of list. So the length here you specify as 4. Remember that sometimes you need to always define your length so that when elements are getting into added into the list, therefore you know what is the capacity of your list. Also, there is a way on how you expand it. I mentioned that earlier. You have to add in a specific function, not function, just a code, a simple logic code that accept and expand your counter, okay, that you use count. So here you have a length of 4, all right, for your list. So increment length of list is it can be incremented based on how many items you put it in it, okay, based on your function. So here it can be until 6 here. That means it shows that it is expandable other than 4. So you want to add in plum at the length length number at location number 4 for this particular list. Okay, so then your available length would be 5 incrementally. Okay, when you add in, it will becomes 5 because first you only put 4 until here. So this one is not visible yet, yeah, but you put it 4. So when one data element is inserted, an element is inserted, so then automatically the length becomes 5 after that. So that allows another element to be added into your list. So that is a call for method add new entry. Next one, adds an item at a specified position. So you requires a utility method like make room to shift element ahead. Okay. You want to insert Carla as a third entry in an array as an element. So you have Alice, Bob, Dog, and Haley in your list. Now you want to add new entry or shift it into a new position. Okay, because you want to add in Carla in that position, number 3. So what happened is you go and get Healy and Dog into a new position. So this is what happened inside your list. You have Alice, Bob, Dog, and Haley, and then after that you move Healy on the other side and Dog on the other side after that. Therefore, you allow Carla to slot into the new position. So this is basically calling for add new position, new entry, okay, operation of your list. So that is the adding. So array of object references. An array of objects actually contain references to those objects. Okay, reference, because that's how you want to search for ability to search for your destination where you want to locate certain data. For simplicity, okay, this is for simplicity, figures portrays arrays as if they actually contain objects. Okay, like this. So basically, it says this is an example of list where all these data are stored, and then each of that has a pointer or actually references like an address. Okay, so that happens in your code whenever you type, like you're searching for a certain data through your input box, which is referring to your search box. Therefore, the system then try to search for that based on the references which you have set, and then it will retrieve the data which you wanted. Okay, for Alice, Bob, Doe, and Healy. Method removes. Method removes basically to try to give position to some other element to come in and removing it or popping it out from the list. All right. So removes the item at a specified position. Must shift existing entries to avoid gap in array. Requires the utility method remove gap except when removing last entry. So whenever you the method must also handle error situation when position is specified and remove is invalid when remove is called in the list is empty. Okay, so these are basically when you want to execute method remove. Okay, so you want to remove one particular element in your list. That moving of element should allow that doesn't have any gap. That means that it automatically filled up that space. When that means it goes back into the normal linear sequence of list, so that there isn't any gap, an empty gap there that causes a disruption of when a search function is executed to locate certain data. Then it goes into that particular empty slot that was removed previously. So it automatically adjusted the list as the normal list where you have a linear data being stored one after another. Okay. So method must also handle error situation when position specified in the remove is invalid. So for example, you cannot basically, when you remove is called, when this particular method is called and the list is empty, so it does not produce error. It's supposed to tell that that is invalid, that is supposed to be uh, not available. So invalid call returns null value. Okay, so you need to be able to handle error situation. Okay, this is removing Bob by shifting arrays entry. See, like this is what I meant. You have Alice, Bob, Carla, Dog, and Haley, and therefore you want to basically remove. Who you want to remove? Bob, Carla, Dog, and Haley. Alice, Carla, Dog. Okay, you want to remove a list entry, which is Bob, right? Yeah, you want to remove Bob so that each of the yeah, Bob will go here, and then after that, Carla will go there. So Dog move the other side until the end, where Haley replaces Dog. Okay, you get what I mean? When you remove Bob, actually this is empty space. So list should be that when you remove one item from the list, these particular data should be able to go back, or this element in the list should be able to go into the empty slot and produces like this space, like there's nothing happened there, because your data or the element has been removed from the list. So it should come back to this kind of arrangement, so that there won't be error, or there won't be empty slot in the middle or empty gap in between all these elements. So this is removing a list entry. It should go back to this kind of arrangement after this one is removed. That's why Carla moved here, and then after that Haley moved there, and then Dog moved there. Okay, so Carla, Dog, and Haley move here, replacing Bob, which basically clarifies three other space in your list, producing empty slots here. Okay, so that is what happened if you do removing a list entry. Okay, so algorithm for other methods include public Boolean replace that you can use, integer given position, and T new entry. Okay, public T get entry. These are algorithm on how you basically use removing of list entry. Okay, so these are algorithm which you can use. Okay, now Java implementation refers to your chapter 4 ADT array list. I have this. I cannot put it in here because it is too long, so I will give it to you like I usually give example for you to refer, because all this basically helps you in checking the code's significance, why you can actually use that, or how you can actually use the program in your assignment. You know, if you want to use a simpler way on how you present your code or write your code in a shorter version or something like that. Okay, more efficient to reduce redundancy. So in the interface list interface, each abstract method corresponds to an ADT list operation. So since the array list class implement list interface, array list contains the implementation of each abstract method list interface. Okay, so that is basically what has been described or explained earlier in the abstract method in the video about you declare and you put all your abstract method which corresponds to the ADT list operation. You put down string to call upon string, or you put T, and then that actually accepts integer as well, and strings, and some other primitive data type which you put under generic data types. Yeah, so this is Java implementation. You would have to refer to array list to see how it is implemented. I will give you that, yeah, after the end of this class. Okay, again, this question arises with what happened in list. So what if the array becomes full, or the array location assign entries? Okay, so this is similar. You assign a counter count that automatically increases, which you have seen earlier. The list is automatically, the length or the size of the array automatically increase once that happen. So there won't be any problem whenever you want to add in an element. Okay, so this is the how you solve that. Expanding an array. An array has fixed size. If we need larger lists, we are in trouble. But what do you do? How do you counter react to this? Meaning you have to solve the problem. When array becomes full, move its contents to a larger array, or you call that dynamic expansion. What happened is you copy data from original to a new location. So there is also a function to do this. And then manipulate names. So new location keeps name of original array, but add the size of the array. So need two utility methods which you can use for expanding an array. One is array full, and which is to determine if a question like if the array is full, then what can be done to the array size. Therefore, another one is double array, can be used to expand the array. Yeah, so
The double array just double the size.
double the size. No, double array is basically you have original array size, which is for example 4, and then you will move to another bigger size array. It will, which is a double of that. Or maybe you can put yeah, one way is that. Another one is double, as in it increases based on the what do you call that? I forgot the term. You put you make it double. I cannot explain that. Okay, meaning you have an array which has a fixed size, and then it moved to a new location which has, see, the manipulate name. So new location keeps the name of the original array, but it is bigger than that. Okay, so but anyway, you can refer to that array list where it can show you how you can do that. Okay, I will show you that. I will give you and add that in your coursework later on. Okay, this one what I meant. Yeah, original array, you have this, and then you want to go for dynamic expansion, and then you copy an array content to a larger second array, like that. So this is, you want to expand, right? An array A, B, and C. An array A, my array, you have this size. And then after that, the same array with two references, which basically point to the same list. And then another one is that two arrays. One is smaller, which is original. We call it old array. And then reference to the original array now to the newer array, which is larger. So you set a size for that. This old array will go into the new array. So you call that my array. Okay. An array B is the same array with two references. And then you have two arrays reference to the original array now, referencing to a new larger array. That is how you expand. So this one is a code to accomplish the expansion shown in figure. Where's that figure? Here, 5.7. The code, yeah. Okay, so this is your integer, my array equals the new integer initial size, integer element array, all array into my array. You save reference to my array, and then my array into a new. So this is what you do when you double it, you multiply that. Okay, I forgot about this. You multiply that with your all array. So that double size of array. Okay, you want to expand the size of array, just multiply, you square it, square the array. Okay, so then you point it into the index or reference of your all array. Okay, all array go into the my array, right? You have a reference index there. Okay, this is basically a code if you want to actually expand your array. All right, I hope they have that in the array list. I think they have. Okay, so you can see the example there in the program. Yeah, program source code. Right. So expandable list implementation. Change the is full to always return false. Okay. We will expand the array when it becomes full. Okay. So you use is full to always returns false, because we keep asking if it is it full? If it is like true, then it always false. Yeah, false means it will keep appending. So we will expand the array when it becomes full. If you use is full is asked. We keep this function so that the original interface does not change. Now, another one is the add methods. Build double, okay, the size of your array. You multiply that with 2 and becomes when it becomes full. Now declare a private method is array full called by the add method here. Okay, so that is how you expand your list implementation. It's all about knowing how you would like to call and declare and create a method that calls certain method in your class. Okay. So pros and cons of array implementation for the ADT list. The pros would be retrieving an entry is fast. Adding an entry at the end of the list is fast. Adding or removing entry that is between other entries requires shifting elements in the array. And then therefore you increasing the size of the array requires copying elements. Okay, so that extra job here is removing and increase the copying elements there. Fast, but you need extra job of removing, and you need extra copying elements to be executed there. Sample code, chapter 4 today. You should have list interface, okay? Trying to show you how it works for list interface, which I mentioned earlier. Array list, and then after that runner, the .java, runner.java. And then for client is registration. So you have ADT, you have entity, and then you have client. Okay, I will look into that. Now stacks. Stacks is how you see it is basically LIFO behavior. LIFO last in first out. New items are added to the top of the stack. Okay, so the item most recently added is always on the top. The most recently added item is always the next item to be removed. Last in, first out. Okay. All right. So that means if you see this tag and all these things, right, whichever is the last one to be put in, first you put this one, second you put this, that you put that. So last thing that you put will be the one that comes out first. Yes, makes sense? Okay. So that is LIFO. LIFO. Basic stacks operation ADT is push new entry, meaning you put in the element into the stack. Pop, you remove the items or the element from the stack. Pick, you check whether there is an empty stack. Is empty, you confirm whether the stack is empty, and therefore you make clearance of the stack. Okay. All right, so those are additive stack basic operation. You know this already. It has been mentioned several times in the previous chapter. And then array stack implementation consideration. When using an array to implement a stack, the array's first element should represent the bottom of the stack. This is what you know. And then the last occupied location in the array represents the stack's top. Yes. This avoids shifting of elements of the array if it were done the other way around. Yeah, so this is basically how the behavior of array stack, right? LIFO, right? Yes. Okay, so this is an array that implement the stack. Its first location references, which is looking at A, and then top of the stack, and then B, the bottom of the stack. Okay, so when you insert element into the stack, the last one will be the last thing that you enter here will be the one that is on the top of the stack. Okay, so your bottom index is three elements inserted, and this is how you stack it. All right, this one you basically put 0, 1, 2, and 3. So, but the way how the program sees it and how it is going to be retrieved is from the top, which is from the bottom. Okay, so last in, first out, LIFO. Okay, so Java interface refers to stack interface.java. This one going to be provided to you as well. I will search for this one. And then data field in Java class and array is to store the entries of the stack. This is basically a repetition of all the ADTs which belongs to list, queues, and stack, just how it is implemented. Okay, an integer variable represents the array index of the top entry initialized to 1 to indicate an empty stack. Okay, this one is your array of stack entries, and then your integer top index, which is reference to your index of top entry. Okay, so this one is there as well, yeah. Okay, so this one, method push new entry adds a new item at the top of the stack, increment top index, assign new value at the array location indicated top index. Yeah, okay, that is method push. Hop is this way. You assign the entry at the array location indicated by top index to a temporary variable to be returned, and then you decrease or decrement top index, meaning you pop it out. Okay, last in, first out, like this, right? So first in, last out, last in, first out. Yeah, so last in would be your 3. Okay, so the top return to client and the top becomes here, number 2, and so forth. Okay, top index is 3. This is how you pop it. When you pop 3, it becomes null, and then you go and look at your top entry, which switches from 3 to 2, element number 2, and then setting array top index and decrement top index, meaning you put this as null, it will go straight point to the second one. After that, this become null, it goes into the second one, and so forth. Okay, so when this is gone, right, removed and clear, then therefore your top index becomes 2 automatically. All right, this is the exercises. Write the algorithm for the method. Convert number to binary, integer number, to convert the given number to its equivalent base 2. Okay. All right. I think I give an example on this one. You want to change integer number, whatsoever number, to a binary codes of 0 and 1. Okay, so base 2. So this one is the using a stack. Okay, and return the result as a string value. Number 1, create a stack of integers. Number 2, while number is not 0, so remainder equals to number is divided by 2, is a divide percentage 2, and then push remainder on the stack, update number, that is number divided by or equals to 2, declare variable binary string as an empty string. While the stack is not empty, then what do? You pop the top, and then you concatenate the top value to binary string, return binary string. Yes. Okay, there is a program on how you do this. I cannot recall. I think I put it somewhere. Where did I put that? I have seen this program before where it is you want to input a set of integers, what it wants you to use, what it wants you to do, and the result as the output is that when you enter a certain integer like 1, 2, 3, 4, 5 or values of any values of that integer, it will return you binary one and zeros. Okay, I think I don't know whether I included that. Let's see. I don't know whether I included that. I did not include that actually. Oh, too bad. Never mind, I forgot about adding that, I think. Right. But you get what it means, right? This one is a basically convert number to binary. Get what it means, right? There is a program called convert number to binary for integer number, okay? Where when you input a certain number, any sorts of number value, and then the result will give you a binary, which is of 0 and 2. Okay, so this is a program for method convert number to binary integer number to convert the given number to its equivalent base 2. Yeah. All right. Sample code would be in your stack interface, array stack, and then your client would be your string reversal. There's so many codes here that you have to see. So that's why this is basically a very long chapter. Okay, so we reach Q. Do you want a break or you want to continue?
Can break.
Continue?
Okay, break.
Continue, okay? Yes,
Uh,
continue.
break 5 minutes.
5 minutes, okay. So we take a break 5 minutes, yeah? Relax
Okay.
your brain because it's too much information. Just take a breather. All right, I'll see you in 5 minutes. Okay. Okay, now let's get back to our lecture. Queues. Are we ready?
Yeah.
Okay, now we are going towards queues. Queue is such that you see in this image, you are lining up. So basically, first in, first out, right? FIFO. Okay. Queue organizes entries according to order of entry, right? Like I mentioned, FIFO, FIFO, whichever you want to call it. All additions are at the back of the queue. So front of queue has items added first. Okay, so like such. Okay, so ADT queue's basic operation would be enqueue, dequeue, get front is empty and clear. So all these functions are described here. So there is a Q Java program called QInterface.java, which we have in the sample as well. There's so many examples of a package here for illustration or for your understanding to refer to for this particular chapter. And data field in the Java class would be an array should be there. And then integer variables, which refers to front of the queue and back of the queue. So this is basically how your array, your front index and the back index is represented in your code. So here it says the array of T uh, basically shows arrays of Q entries, and then integer front index of the front entry, and then back index. This one refers to the back entry because Q is like a train. You can actually add in the front or at the back, or you remove the back or the front. Okay, but basically it performs FIFO, first in first out service. So linear array with fixed front, there is an array queue implementation variation, the types of array queue. Number one is linear array with fixed front. Okay, a linear means one after another, and then it has a fixed front. Okay, meaning you basically just have FIFO. Okay, how you do service, you are being first in first out, that's it. Linear array with dynamic front. Okay, so dynamic means it keep changing perhaps from the first one going to the second one accordingly. And third one is circular array, which goes from front to the back like a circle, circular array. So this is a method for linear array with fixed front. Okay, so the front of the queue is fixed to Q0. Okay, and then for example, that is your front index is always 0. Back index initialized to 1 to indicate an empty queue. This is fixed front. Okay, so method enqueue for the fixed front would be increment at the back index because the front is fixed. So you assign new values at the array location indicated by the back index instead of the front index. But this is what it is, right? When you want to line up, you basically add from the back because those who are already in, you should find your way to the back for the next line, right? So this is enqueue. Method dequeue is assign the entry at array location 0 to a temporary variable to be returned. Shift entries from array location number 1 to back index one step towards the front of the array. Okay, this is what I mentioned. It goes from 1 to the next one, 0 to 1. Okay, and then it is decrement back index. You decrease from the back So therefore your location from 0 going to 1, just like a stack, 0 empty, then it moves to the next one, number 1. Method is empty. Method is empty is simply how you want to get rid of your queue. The queue is empty. You check if your back index is equal to -1. Okay. Strength and weaknesses, easy to understand as it is similar to how everyone else is in queue moving forward a step. Okay, when you move forward, somebody else already given being service, and therefore the last one becomes to move forward, and that particular person in the front becomes number 1. Okay, the DQ operations is inefficient. There's overhead incurred as must shift entries each time we remove an entry. Okay, this is inefficient because every time you want to check, because you are trying to see from the back, that has to be removed to the front. Always you have to shift entries each time when you remove an entry. Okay, so that is DQ weaknesses. Method number 2, linear array with dynamic front. Front index is dynamic, meaning it's active. We instead move, or you call it update front index. So you keep updating your front. Back index initialized to -0, front index initialized to 0. Okay, so this is dynamic. Keep updating. The one just now is that if it is empty, then therefore you have to move from the back to the front. This one is that dynamic. You keep updating regardless of any activity. Method and queue, increment back index, assign new value to the array location indicated by back index. That is NQ. DQ, assign the entry. I believe I gave you a video on queue the last time, how this process of NQ and DQ is happening, right? Okay, so this is method DQ, assign the entry at array location front index to a temporary variable to be returned, and then after that you increment front index. Keep appending the front. Okay, DQ is looking at the front and Q is at the back. Oh, is it the other way? Okay, look at this. Front index, back index. Okay, so your front index is entry at front of Q, entry is at the back of Q. A, an array that represents a queue without shifting its entries. A initially, B after removing the front twice. So you are basically keep updating after you remove, everything has to be shifted to the front. Okay, so in B, number 2 would be your front index. Number 5 would be your back index, because first you have already removed 0 and 1, and then after that, that arrow or your pointer will move towards number 2. That becomes your entry at the front of the queue. So that moves to number 3 after that. Okay, that is a array, how you present queue without shifting its entry. Usually you shift the whole thing to the front, but this one you move the pointer by referring to the element on its location without shifting its entries. I mentioned here. All right, so method is empty is, you know what this is. This is just to get rid of checking whether your back index is less than your front index, or meaning that empty or still something is in the queue. Yeah. Okay. So strength and weaknesses, do not have to shift entries after each DQ operation. Problem, right word drift. For example, it is the array can become full when the last array location has been occupied, but there is an empty location in the beginning of the part of the array. So it doesn't actually move towards that, but it pointer points towards next entry because it doesn't move. How to use the empty location? So how to use that is basically you need to point your reference to the second one. Circular array. Data field, when Q reaches end of the array, this is circular here, it's like a ring. Add subsequent entries to beginning. Okay, arrays behaves as though it is circular. First location follows the last one. Back index initialized to -1, front index initialized to 0. Same like the one which is previously, but this is in the circular version. Use modular arithmetic to update indices. Okay, back index +1, and %array.length, front index. Okay, this one is a modular arithmetic, which refers to this, yeah, which you can use in if you were to use this method circular. So this was the explanation. An array that represents a queue without shifting its entry, similar to the previous one. And C, after several more additions and removal. Okay, and then D after 2 additions that wraps around. Okay, let's see one by one. C, D, A. Okay, A is when it's full. B is after moving 2 entries from here. C is after removing 3 entries from here. So what happened to the first place here? It becomes empty as well. Okay, like here, front index is 47, back index is 46. So that is a circular. It should be like a circle. This is 46 is your back, this is your front. So next one, B, is after removing 2 entries, which is your front index, and the subsequent entry, which is after your front index. That this is what happened. Your front index moved to 49 because this is previously your front index, and then remove this one. Then the first reference for your front index moved to 49 at element 49, and your back index remains at 46. Okay, and then at C, after removing 3 more entries, which means that you want to remove 49, 1, and 0. And therefore, what happened is your front index, okay, because you removed this one was previously your front index. And then it goes into, you remove another 2 here, and it goes to 2 would become your front index now. Okay, and then your back index remains at 6. So it's like moving in a circle, okay, circular manner. So that is your circular array. And here, after several more additions and removal, this is what happened. See, okay, keep going round and round till the last of your elements, which is inside your array. 47 becomes for your front index, okay, and 49 would be your back index. Next one is your D. After 2 additions that wraps around to the beginning of the array, okay, pay attention, your front index is still under 47. And then you have removal wrap around, which you push your index, okay, your front index goes to number 47 still. Your back index, which was previously on 49, move forward because it is moving around like a circle, goes to here, entry of the back. So the back index becomes 1. Okay, so I think there needs to be an illustration of this to understand this further. Uh, Maybe next time I can include a video for us. Okay. All right. So next one is the NQ. Okay, this one is done here. NQ. Okay, done. Right now. Okay, so this is method DQ. Let's see. DQ, right? We've covered NQ and then DQ are here actually. So we covered this one. Yeah. The last few parts I will continue during our lecture. A little bit more. Okay. Yeah. Later on, I will include the video of how this queue moves. I think better, right? Circular array. Okay. So we stop here. Okay, we stop here for this for now. Method NQ. Basically, update back index using modular arithmetics. Okay, and then assign value to the array location indicated at the back index. Okay, if I were to just talk about this by words, it is not really showing any much of understanding. I will find a video where you can actually see the illustration on this, which I will continue later at 2 p.m. Yeah, yeah, I think so. Yeah. Okay, so any questions so far on the lecture notes? It's very, very long, right?
No.
Basically,
Yeah.
these things you already encountered before. It's just that it is a elaboration in detail on how it moves. Because after all, what you need to know for today is basically implement the ADTs list, stack, and queue using arrays. Discuss the strength and weaknesses. Pay attention to that of using arrays to implement ADTs. And then you need to see efficiency of the arrays implementation of the ADT. So these are the three things that you need to know for this chapter. Okay, so basically there are a lot to learn, a lot to absorb, a lot to see. Okay, we will continue later on the rest. Let me find a video to illustrate this array. Okay, so you can absorb it easier, right? Okay, so do you have any question?
No.
No?
No.
No. Okay. What do you think of this chapter? Tedious?
Okay.
You can follow so far?
Yeah.
So far can follow.
Okay, so far
Do
good.
can we just use InQ and DQ instead of
Pardon me?
instead of writing our own code about it? The InQ.
Again, sorry?
Can we just use the InQ command instead of writing our own codes to do the
You mean
InQ?
you want to use the example codes?
Yeah.
In your which one? Your assignment?
Your assignment.
No, cannot use whichever example that we provided for you.
Okay.
But don't worry, you don't need to use what we provide for you, but there are a lot of resources online where you can find, and you can what you can actually refer and reuse and change a little bit of how it functions according to what you want. Correct? So you need to do what you know. What you want to do now is you want to know the concept of how it functions. Then therefore it is easier for you when you have found which is the most dynamic for your program, and search it exactly what it is online and adapt it. Use your the codes which you have from the resources online. There are a lot, right? And then implement it in your program system how it works. So don't like the instruction which was mentioned inside the assignment. You are not supposed to use whatever samples that you have here and copy and paste it in your program. Cannot. Okay. So what you have to do is, if you use that, they will put you. They will do evaluation based on the lowest what you call the PLO, program learning outcome evaluation, and see that you have not actually explored further on your code to be adopted. So I think to be safe, you don't use whatever it is here, but you use it as reference to find online codes which are similar. Get what I mean?
Okay.
Mm. Okay. So with that, I'll see. We will conclude today's lecture session. Very, very tedious, very long session, right, for these lectures. I see you at 2 p.m. Okay?
Okay. Give me a
All
second.
right. Thank you, class.